This problem has you using the formula Q equals m delta TCP, where Q represents the amount of energy in joules usually, m represents the mass of the object that's getting heated up or cooled down, and delta T represents the change in the temperature. It's positive if it heated up and negative if it cooled down. Cp has to do with the specific heat of the material. And it changes depending on what material you have. So looking at problem number 1, we've got 400 grams. Grams is a measurement of mass, so we know our mass is equal to 400 grams. And then we look and we see that the temperature went from 10 degrees to 20 degrees Celsius. That's our change in temperature. We can get that by taking our final temperature, which is 30 degrees Celsius, and subtracting our initial temperature, 10 degrees Celsius, and we get our change in temperature. It's a positive value because it increased, and then we're trying to find how much energy. So Q is what we're trying to find. So Q is how much energy did it take to heat that up. We know that our specific heat Cp of water, it gives that to us as 4.184, and those are the units afterwards, which is how many joules it takes to raise 1 gram of water 1 degree Celsius. Now we just need to plug them into the formula. And I'm writing this as -1, which just means divided by. So when we plug it into the formula, we get Q, which is what we're trying to solve for, is equal to the mass, which is 400 grams, times change in temperature, which is 20 degrees Celsius, and then we multiply that by the specific heat, which is 4.184 joules per gram per degrees Celsius. Now, the degrees Celsius cancels, grams cancel, and we're left with the units of joules. So what we need to do is plug this into the calculator, and we take 400 times 20 times 4.184, and we get 33,472. And this is joules. So our answer right here, that's how much energy it would take to raise 400 grams of water 20 degrees Celsius. The next problem, we're using the same formula, except for now we're dealing with iron, and we plug it in. So we're trying to solve for how much energy again. So we're trying to solve for Q again. So Q is equal to the mass of the object, which in this case is 380 grams of iron, and we multiply it by the change in temperature. It already has calculated the change in temperature. It tells us is heated 400 degrees Celsius, so that is our change in temperature. And then we have the specific heat of iron this time, which is only takes 0.45 joules to raise it 1 gram of it 1 degree Celsius. Again, the degrees Celsius cancels and grams cancel, and so we're left with the units of joules. Plugging it into the calculator, we get 380 times 400 times 0.45, and we get 68,400 joules. In the next problem, we are given joules, which is Q this time, and we're given mass. What we're trying to solve for is delta T, how much the temperature of water increased by. So when we plug this in, this time we have Q is 1200 joules, and we have the mass, which is 250 grams, but we don't have delta T. So that's going to be the variable that we're going to solve for. And we don't have given in this problem the specific heat, but we know it's water. So if we look up to the problem we did up above, the specific heat doesn't change for the substance. So we can use the 4.184, and it's joules per gram per degree Celsius. And this time the grams cancel, and we're going to end up having to do some algebra to solve this problem. And we're going to get delta T by itself. To get it by itself, we've got to divide both sides by 250, which grams is gone, so 250 on this side. We also have to divide both sides by the 4.184. When we do that, we cancel out, oh, I'm sorry, grams, and we divide this side by the 4.184 also. And everything gets canceled on this side. And so to get our answer, we take 1200 joules, and the joules cancels. Degrees Celsius, grams cancels, and we're left with 1 over Celsius to the -1, which the inverse of -1 puts it up on top. And so we're going to end up with the units of degrees Celsius once we've canceled them out. So to get our math on this part here, we take 1200 and we divide it by 4.184, and we also, since 250 is on the bottom, we divide it by that, and we get 1.14 degrees Celsius. Yeah, 1.15 would probably be a better, since we're rounding up, degrees Celsius. The last problem, we're trying to solve for how much energy does the Dorito chip have. In this scenario here, we've got a pop can with some water up above a Dorito chip that's burning. The Dorito chip that's burning is transferring the energy into the water. If we assume that all the energy goes into the water, then if we know how much water or energy the water gained, that's how much energy the Dorito lost. So the water gained, we can use the equation, the Q is what we're solving for, and how much energy the water gained. We know the water weighs 300 grams, and its change in temperature, it increased by 2.5 degrees Celsius. That is gotten from subtracting 16 from 18.5. And the specific heat of water is 4.184 again. And so if we do the math, we take 300 times 2.5 and then 4.184, we get that there was 3,138 joules released into the water, which is how many joules the Dorito chip had. To convert that into calories, we just need to divide that value by 4.184. That's how many calories there are, and there's 750 calories.